All right. For number 13711, that first section, I'm just going to talk to you about some integer properties. For example, one of the first properties I want to talk about is any number raised to the 0 power is going to be the integer 1. Okay, it doesn't matter what that number is, so I could say 3 raised to the 0 power is going to be 1, and you can test this on your calculator. Your calculator will prove that it's true. 4 raised to the 0 power is going to be 1. Any number raised to the 0 power is going to be 1. Now, something you have to be careful about is sometimes in the book they throw a negative sign in front of your value. So negative, let's say 5 to the 0 power equals, well, what does that equal? First, you have to understand that an exponent only sees what's right in front of it. So that exponent of 0 only sees the 5, okay? It doesn't see that negative sign in front. So the 0 looks at the 5 and it says, okay, I want to apply the 0 power to the 5. That turns that into a 1. So just the 5 turns into a 1. That negative sign is still out front because the 0 only applied to the 5. Another instance you might see, let's try this same problem. But if I put parentheses around the negative 5, well, that's different because that 0, that exponent, only sees what's right in front of it. That 0 sees the parentheses now, so that 0 is going to apply to the parentheses and everything inside the parentheses. All right, so now we have the 0 applied to the negative 5. That means everything inside the parentheses turns into a 1. Okay, see the difference? Up here, the 0 only applied to the 5. Right here, the 0 applied to everything inside the parentheses. The exponent only sees what's right in front of it. Okay, let me extend that idea with a few more examples from your book. For example, what if I have a fraction inside the parentheses raised to the 0 power? Hey, what does the 0 see? The 0 just sees that parentheses. So the 0 exponent is going to apply to everything inside the parentheses. That means it turns everything inside the parentheses into a 1. Easy enough. How about, let's talk about parentheses again. I'm going to raise something in the parentheses to 0. Remember, it doesn't really matter. The 0 applies to the parentheses. This 0 only sees what's right in front of it, that parentheses right there. So it's going to change everything in the parentheses to a 1. No matter what I put in the parentheses, your example puts an a squared plus 1. I'm on page 17 if you want to follow along. Your example puts a squared plus 1 in parentheses. We are raising this entire group to the 0 power, so again, it just turns into a 1 because the 0 applies to what's right in front of it, the parentheses. Okay, let's talk about negative exponents. Negative exponents, whenever you see them, that's something we're going to have to straighten out. And the only problem with negative exponents is they are sitting on the wrong side of the fraction bar. What's a fraction bar? Well, anytime you see a fraction, say 3 over 4, I'm going to call this the fraction bar, okay? So if you see a number with a negative exponent, for example, 3 to the negative 2, the first thing I would do is turn this into a fraction if it's not a fraction already. So I'm going to put it over 1 because we can put any number over 1. There, I have a fraction. I'm going to put an equal sign beside it. And now I'm going to straighten it out. I see that the 3 has a negative exponent. That just means it's on the wrong side of the fraction bar. So the 3 to the negative 2 is on the top. I need to move it to the bottom. Here's my fraction bar. I need to move it to the bottom, and now my exponent becomes positive. Okay? What's on top? If there's nothing on top, just put a 1 up there. All right? So just remember, anytime you see a negative exponent, that just means that it's on the wrong side of the fraction bar, and you got to move it to the other side. All right, let's try another one. From your book, I'm on page 17 again. We have 1 over 4 to the negative 3. Okay? I always start by drawing my fraction bar. Then I look for negative exponents. And anything that has a negative exponent, I just move it to the other side. So 4 to the negative 3 is on bottom. That means I need to move it to the top. And once I move it to the top, that 3 becomes positive. All right? You have a 1 on bottom. If we simplify this a little further, anything over 1 is just itself. So 4 cubed over 1 is just plain 4 cubed. So we could simplify that a little bit further. All right, another example from page 17. We have 5 to the negative 2 over what? 7 to the negative 1. 7 to the negative 1. Okay, I always start by drawing my fraction bar. And anything that has a negative exponent needs to move to the other side. So my 5 has a negative 2 exponent. That means that 5 needs to move to the bottom. And when it moves to the bottom, that negative 2 becomes a positive 2. The 7 has a negative 1 exponent. That means the 7 needs to move to the top. And that negative 1 becomes positive 1. Now we can simplify this a little further very easily. 7 to the 1. 7 to the 1. Remember, anything to the first power is just itself. So 7 to the 1 becomes simply 7. Now 5 squared, that's easy enough. That's 2 5s multiplied together. 5 times 5 is 25. And there's our simplified answer. Okay, now I want to show you one more thing that might trip you up on problem number 11. I'll show you a little example here that'll help you with problem 11. If you see, for example, negative 5x to the 0, and you want to simplify that. Now remember, our exponent, 0, it only sees what's right in front of it. Okay? It only sees the x. It doesn't see the 5, and it doesn't see the negative sign. All it sees is the x. So let's take care of that. Let's raise x to the 0 power. Well, that turns into a 1. Our negative 5 is still in front. Now that looks like negative 51 the way I've written it. So let's think. What's happening between the 5 and the x? That's multiplication. So we want to make sure that when we bring it down, that it's still multiplication. So we can use a little dot to show multiplication. We could also use parentheses to show multiplication. Either way is fine. Okay, so now we have negative 5 times 1 simplifies to negative 5, and there's your answer. So just remember that the exponent only applies to what's right in front of it. All right, so next example, I'm looking at negative 7x squared y to the 0. And I'm looking at anything I can simplify here. Really, the only thing I see that I can simplify is that exponent of 0 that we just learned about. Remember, the 0 only sees what's right in front of it, so it only sees the y. So it's going to turn that y into a 1. What about the x squared? I can't think of anything I can do with it, so I'm going to bring it down. What about the negative 7? I can't see anything that I can do with it, so I'm going to bring it down. And just to make sure I understand what's going on here, I'm going to put dots in between each one to show that that's multiplication. Because remember, above it was 7 times x squared times y to the 0. And when we bring it down, it's negative 7 times x squared times 1. Well, we can multiply the negative 7 and the 1. So negative 7 times 1 is negative 7. And we still have our x squared hanging around. And we could put a dot in there if we want to, but that's really just extra writing. So let's just leave it negative 7x squared and call it good. Okay, so remember, the exponent only applies to what's right in front of it. All right, let's pick up at number 18. I think you guys have enough information to do the homework up to that point. The assignment's actually number 17. I'm just going to do the one right next to it. I'm going to do number 18. It's just like number 17. So you can work number 17 just like number 18 that I'm working here. Okay, we're looking at uv in parentheses raised to the 6th power and u squared v in parentheses right next to it. Now, why did they bother putting parentheses right here? That's just to show that we are multiplying. Okay, remember, anytime there's parentheses next to each other, we are multiplying. So we have uv to the 6th times u squared v. Well, we got to talk about some properties of exponents here. I'm going to write the uv a little bit bigger. Okay, I'm going to go ahead and bring down the u squared v. Alright, properties of exponents. You got to be careful when you see an exponent hanging around outside the parentheses. Okay, that means you need to raise everything inside of the parentheses to the 6th power. Well, how do I do that? Well, first I have to know what the exponent is on the u and v inside my parentheses. Well, if you don't see an exponent, we assume that it's an exponent of 1 because anything raised to the 1st power is just itself. So you can basically put a 1 exponent on anything that doesn't already have an exponent there. Okay? We're just too lazy to write that 1 every time, so we leave it off. So u is being raised to the 1st power, v is being raised to the 1st power. And together, inside that group, they're being raised to the 6th power. So let's do one piece at a time. We'll start with the u. The u is being raised to the 1st power and then raised again to the 6th power. Whenever you raise a power to another power, you just multiply those exponents. So we're going to multiply the 1 times the 6 to get u raised to the 6th power. The v is the same thing. V is being raised to the 1st power and then being raised to the 6th power. We just multiply those exponents and end up with v to the 6th. Okay? I'll go ahead and leave the parentheses on for now because we are still multiplying by u squared v. Alright, now if you look at this, everything here is being multiplied. U to the 6th times v to the 6th. Now, parentheses times another parentheses means we're multiplying. Anytime parentheses are beside each other. The u squared is being multiplied by the v, so really, all this is just multiplication. And we don't need the parentheses anymore. We'll just write it all as multiplication. Okay? Alright, now what do we do with those? We are going to multiply this u. We're going to multiply this u times the other u. And if you're just multiplying bases together that are the same, if you're multiplying u's together, you just add the exponents. I'm going to move up here. So, u to the 6th times u squared times v to the 6th times v. What's the exponent on that v? Remember, if you don't see an exponent, put a 1 there. So all I did was group the u's together and group the v's together. Multiplying u's together, we just add the exponents. Alright, think about it. If you have 6 u's being multiplied and then 2 more u's being multiplied, altogether you have 8 u's being multiplied. So u to the 8th, same thing on the v, add your exponents, v to the 7th. So final answer, u to the 8th, v to the 7th. Alright, so what you need to remember is, anytime you raise a power to another power, you multiply the exponents. Alright? And if you are multiplying a u times another u, or an x times another x, or a y times another y, you just add the exponents. Okay?